Hello everyone. I am so excited to be with you in this session in Developer Day. Our title of this session, Machine Learning Roadmap from Zero to Hero. Let me introduce myself. My name is Ruqiya Bin Safi. I am Google Developer Expert as well as Women Techmaker Ambassador. I start my career path as software engineer. Then I move or switch to machine learning. So I have both background in developer software or as developer or software engineering as well as machine learning data science. Now or currently I work as machine learning researcher at Bayan. I am a member AR&D development and research at Bayan, which focuses on artificial intelligence and data science. Also, I am a consultant, a machine learning consultant at Quebec. That's about me and my background. This is my handle on Twitter. If you have any question or want to contact with me, this is my handle on Twitter. Agenda for this session. We will start what is the machine learning, why we need learning machine learning, and roadmap for self-learning. It's a plan for self-learning, steps for machine learning project. The steps contain many phases or many steps. Start with define and framing the problem, data preparation, explore the data analysis, DA, dealing with misdata or misvalue, data transform, data visualization, how we can choose and train our model, how we can test and evaluate our model. Then if our model good enough, so we can predict or use or deploy our model. So let us start. We will start with what is machine learning. Machine learning is built for study or the studies that give us the ability to automatically learn and improve without explicit program. What I mean, in the traditional program, we our input the rule, we write the rule by ourselves, and data give the data to the program. Then the output the answer. In machine learning, no, we can't write the rule by ourselves. So machine learning the output of machine learning the rules. So the input, the answer, we give the algorithm or machine learning the answer and the data. So machine learning give us the rules as output. So we apply the rules for any cases, for any problem. That is the difference between the traditional program and machine learning. I hope it's so clear. So machine learning field that provide us the ability to automatically learn and improve our model and learn from data, from example, from labels. So why we need to learn machine learning? Machine learning today apply in many fields, and traffic prediction, web search, offline detection, forward detection, medical in the medical field, test and speech recognition, email spam or not spam, filter emails, image, and so on. In every now, or not every, most of our application use machine learning, because it is facilitate our life, make our life very easy. And as we say, we just apply the rule, just the input, data an example for many cases, and the output the rules, or the rules that apply. So we can use machine learning in every application. If we have data, so we can apply machine learning for most cases. So now we want to self-learning, or roadmap for self-learning. Can we learn machine learning by ourselves, by self-learning? Yes. This is my plan for learning machine learning. We start learning basic concepts. First step for self-learning, basic concept of machine learning, relation, every science each other. For example, we have to learn what is artificial intelligence, what is machine learning, what is deep learning, what's the relation between these fields and data science. So artificial intelligence is the technique which enable machine learning to mimic human behavior, like human. The machine like human, or behavior of a machine like human. Machine learning subset of AI, of artificial intelligence, which use a statistical method to enable a machine to improve the experience. So machine learning subfield of artificial intelligence, and deep learning subfield of machine learning. Deep learning use the neural network and need more of layers, more of data, multi-layers of neural network. Data science, the study of data, and combine multi-fields like static, like math, like the domain expertise, and so on. So the first step in our plan is start learning about the basic concept. The second step for our plan is start learning Python. We need Python. Here, many resources for start learning Python. I will give you this slide. If you click, this is many courses to learn about Python. The second step, learn Jupyter, the tools, Jupyter, Aconda, Google Colab. It is tools for start applying or write your code. So here, resources for learning, Google Colab, Aconda. Third step, we need to learn about how we can use the tools that we need for write the coding, for apply machine learning, like Conda, Jupyter, and Colab, and there are many tools that I didn't mention them in this slide. Fourth step, analyze and visualize the data. we need to Panda, which for manipulate the data or read the data like tables or display data in tables. Matplotlib for graphic, and NumPy for math. It is used for math and matrix. 5 steps for self-learning. Learn about machine learning concept and algorithm. Then apply it. One of library that famous and very easy scikit-learning. So you need start with scikit-learning because it is very easy and contain all or most algorithm of machine learning. If you use scikit-learning, we didn't use or need to go deep in the math because everything like library, just improve library in this framework, scikit-learning. 6th step, which final step, we need to learn about deep learning, which the last step or in machine learning. It is subset of machine learning, which use a neural network. There are many framework for deep learning like TensorFlow or Keras or PyTorch. Now Keras is built in TensorFlow, so you can import Keras from TensorFlow directly. There are many resources. For example, this is very useful course, Deep Learning AI and Fast AI courses, which are also free. I recommended these courses, and there are also many if you search in Google about deep learning courses or resources. And also you can find useful tutorial in YouTube. Another roadmap. This is a roadmap. How to get started with machine learning. This is very useful. If you click in this roadmap, you can get the resource for each part. I found this roadmap in internet. So if you click, there are many resources, useful resources for start machine learning. So first step, machine learning problems. You have to learn about problems. For example, classification, regression, clustering, and this is resource for that. Also learn about how to learn machine learning. Many useful resource. I will put the link of slide in the chat to get the resource. So I hope you get the big picture of machine learning and how continue learning machine learning by yourself, and you have roadmap, recommend steps to start in this field. Let us start machine learning by example and apply steps. So, steps for any machine learning project. First step, define and framing the problem. In most machine learning, but not in most, in every machine learning, the first step in any project, define and framing the problem. Gathering the data, prepare the data, feature engineering, choose the model, train and evaluate, prediction, deploy. In some resources or resource to learn in machine learning, here 8 steps, maybe be 7 or 6, but the main concept usually is similar. For example, here there are 5 steps: frame the problem, get the data, explore the data, model the data, communication. So, in the frame, we want to learn or focus in the goal. What do you, if you have all data, so frame, we explain this point, frame the problem or define the problem or what the goal of problem. You need many skills and you need many tools for every steps. For example, get the data, maybe you need web scrubbing, data clean, querying in the database. You need the tools like Python, like Panda, and explore the data, plot the data. You focus in the plot the data or chart, for example, chart or graphs or and so on. You need to recognize the pattern and your tools like Matplotlib, NumPy, Band, and so on. Define and framing the problem. This is the first step. Let us explain together what I mean frame the problem. So, as we mentioned before, the first step is frame the problem. Framing is a way to structure the data or present the problem or the issue. For example, here a problem. What is the problem? The evaluator is too slow or the lift is too slow. If we put the frame of the problem, the evaluator is too slow, so the solution depends how we frame the problem. So the solution depends on the frame problem. So here people want to get the solution. So one of them, install a strong monitor, replace the lift, make the evaluator faster, and so on. Please please look to the solution. The solution here depends on how we frame the problem. If we reframe the problem, like here, the problem is the waiting is annoying. So the solution will be different because the frame of problem different. So the solution, music or something, make the waiting or feel of waiting shorter. Depend on how we frame the problem. Next step in any project, gathering the data. In this step, we focus on getting the data. So, if data structure, unstructured, semi-structure, all of data type useful in this stage or step or phase. The potential resource for gathering the data, websites, social media, open data, enterprise data, and put all data that you need in a data pool or data warehouse or data lake. Merge all resource of data. And as I mentioned, maybe from internet, API, website, so web scrubbing, or API, social media, Facebook, Twitter, LinkedIn, CRM, sensor, and maybe a database of any enterprise, and so on. In some cases, we have already data collected. For example, this is resource for repositories that already have data collected before, which let us click here. This is Kaggle, for example, contain a lot of data. If you search any data related or you are interested, you can find about it. This data is very useful if you have a project for learning, not custom project. You can use this data for learning, for everything else, for research in some time. But if you have or project for example, for your company or enterprise, you have to gather data by yourself. Then we have data. And then we have to prepare this data or pre-processing this data. What is the purpose of preparation data or preparing data or reprocessing data? Convert the data from initial format that to the format that may be better for analyze or training the model. We have many issues in the raw data, like misvalue and so on. So we convert the data from initial format to format that be ready for training, for input to the model and for analyze. So the major taxes in data pre-processing or data preparation: exploratory data analysis. The main goal from this task: visualize or understand the data, clean the data, transform the data, visualize the data. This is the major task. In exploratory data analysis, it is approach for summarize, visualize the goal, understand the data. So just summarize or visualize the data to get the big picture of data. Clean the data. So we handle and clean data with misvalue, the outlier, correct format in some cases, remove duplication record, and so on. How we deal with misdata? So there are two steps. Identify the misdata and deal with this data. After identify the missed data, if we have missed data, there are two methods for deal with missed data. Either drop data or replace the data. Drop the row or drop the column. Depend the situation or case. Replace the data by mean if numeric data or median or frequency, or replace with based on other function or inference or other model, depend on the situation or cases. Which the better method to deal with this missed data. Next, transform the data or data transformation. Maybe it's the data we have categorical data or numeric data. In every case or every category or type, categorical or numerical, we have method for transformation. For example, transforming categorical data. What I mean with categorical data, it is maybe a string or object, like color is red, orange, blue. This string or object cannot fit in the model because it is a string. We have to replace or transform the string or object to numbers, because the model or computer didn't understand a string or object, just understand number. So that's the goal from transform categorical data. There are many ways for transform categorical data. One of them label encoder and one hot encoder. In label, look here, country is a string. Using label encoder, we transform country to numbers like index, Japan 0, USA 1, and so on. In one hot encoder, we replace either 1 or 0. And the unique value in this column be other column. For example, here, country Japan. We put 1 if we have country Japan, we put on. If we don't have, but 0. So either 1 or 0. USA, country USA, country India, country China, and so on. So the unique value here, and either put 0 or 1. In some cases, we need transform numerical data. In categorical data, we need to transform because the computer didn't understand the string or object. But in numerical data, in some situation, we need to transform. We have two methods for transform: normalize and binding. Normalize to transform the data to the same scale, and binding to make the numerical data discrete or like categorical. In the transformation, or normalize, sometimes with the same feature. Like here, we have different range or scale, so transform to the same scale. Or we have in two different features, like for example, age and income. So when graph age and income, we can't graph this or present age and income in the same graph um, easily, because this is usually the range of age between 1 and maybe 100, and the income 1,000, maybe for example 20,000, or and so on. So we make it in the same range. Binding like age. So we put it in the group. For example, age from 1 to 0 in the group. From 10 to 90, and so on. So group and make continuous a numerical variable into discrete variable dense. Like age in the survey. Data visualization refer to graphical presentation. Charts, graphs, timeline, maps, and so on. There are 4 top libraries in Python: Matplotlib, Plotly, Seaborn, Altair. This is the top library for visualize the data. Feature engineering. What I mean with feature engineer, the processing for using domain knowledge of data to choose or create new features. So we use our knowledge to choose just features that related our problem, or create new features. Why? To work more accurately, to make our model more accurate. There are many methods for feature engineers. Feature construction, new feature. We create new feature, or combine multi-features, or uncombine feature. Or this is the famous one, feature selection. Select many features to a few that are useful in our case, or our not all features useful for our model, just a few. So we select just the few that related our model and fit it. Choose our model. What is the best algorithm for applying in our model? In machine learning, there are the famous method in machine learning: supervised learning, unsupervised learning, and reinforcement. In many cases, semi-supervised learning. So, but this is the 3 is famous. Supervised contain classification and regression, and supervised clustering and dimension reduction. Reinforcement also we use it in, for example, in game, in robot, and so on. Let us start with supervised learning. Supervised learning, we learn the model. So the input, the data, and the notation of data. Say, hey model, this is an apple. So when use the model, say model, what is this? And the model that learn this is an apple, so the prediction an apple. So learn from example, from labels, from annotation to input. In unsupervised learning, there are just data. So the model try to find the similarity and put the same object in the group. Find the similarity, observe the data, and clustering, for example, clustering the data. So this is unsupervised learning. Reinforcement, no data, just agent and environment. The first step, the agent observe the environment, select action using the policy. So this is the action, go to fire. And for any action, there are reaction, get either reward or penalty. So if get reward, update the policy. If get penalty, update also the policy. So the fire bad. So next time avoid it. Update a policy to be until the policy or get the optimal policy. This is reinforcement learning. How we can choose the best model or the best model? Start this for scikit-learning. Start ask question: is the sample greater than 50? If yes, continue. If no, get more data. So next, is the data have categorical data? If yes, so go to next question. It's have label. If label, so it is supervised learning. So we can use classification. If have label, annotation or example, so it is supervised learning. So classification. If not have label, so we want observe the data or cluster the data. We don't have example. So go to clustering. If not categorical, let us return. If not categorical, ask if quantity. If yes, maybe regression. If no, looking. If it's structure or not structure. If yes, go to dimensionality reducing, and so on. This is like roadmap just for choose your model. Ask question, depend the question is, go or select your algorithm. Algorithm like a classification or clustering or regression or dimension reducing. Then after select your model, algorithm of your model, you need to training, after training, evaluate your model, test and evaluate. So training and evaluation. This is like roadmap just for imagine what happened exactly. So we have data set, raw data set with label. This is, for example, for supervised learning. We have data and label. If you have label, so
That's mean supervised. The next step, preparation the data. After preparation, let us assume already preparation the data. So we need feature extraction. Just select the features that useful for our model and fit the feature matrix, the feature that extraction to our model. Train the model and the output of training ready to test and evaluate. If you evaluate the model and get good result, okay, use for predict on and deploy and use the model. If we got the bad result, so we need to retrain or return back, go back, and maybe we need to re-extract the features or retrain the model. We by training and return this step until we got good accuracy. It's good enough, so that's ready, the model ready for prediction. This is new data. We have to apply the same feature extraction. So if we have in this five column in train, for example, five features. So input for prediction, five value, like as training, same apply same feature extraction, and the result, the label. For example, if this is apple and label apple, so the result will be apple.
Model okay, so now we have training the model. So model is ready. We want to evaluate the model. There are many matrices for evaluation. For example, for regression, we have root, mean square error, and mean absolute error. For classification, we have matrix. For example, convolution matrix, classification accuracy, log accuracy, and there are some issues. Usually, we have some issues underfitting. That mean our model didn't get any good result, either training set or testing set. Overfitting, the result got in testing in training set, but bad in testing set. The right one or the best one, adjust, not over, not under. Not under, not over. So this is the optimal case or the best case. Now our model ready for prediction. There are sometimes we have issue in the prediction when input for our model feature that not match with what feature extraction. So this is the problem. called data mismatch. If the input for prediction not match the input in the training step. Now our model ready for deployment. For deployment, we can use classic, or we can use if you use TensorFlow and Keras, we can transform or convert it to JavaScript using TensorFlow.js and deploy it in GitHub. This is code. You can return to this code. I think I didn't have time to go through code, but I will put the link of slide in the chat. And that's it. Any question?
So there haven't been any questions yet, but people are able to ask them in the Q&A tab if they wish. If there aren't any questions though, we could wrap it up there.
I put the link of slide in the chat. If you have any question. There are a lot of links for self learning, for like here, roadmap, our resource, many resources. If you click, many resources in the slide. So if you want more information, you can return to this link.
Will you be tweeting it out? Tweeting out? Okay, so no questions have come in. Shall we call it there? Thank you very much.
Thank you all. Thank you so much. And goodbye.
Thank you. Bye.